Now, again, the whole point of all this is to avoid the daisy chain effect of switches, the ad hoc, just string them together kind of engineering, let's call it. And it could mean way more than two symbols here in these diagrams that you're looking at. I mean, you see me right here, I've got two devices beside each other. But there's no reason that this can't be scaled up and expanded out very large like this. This is just a model to convey the fundamental concept. And this concept is actually huge. The proper term is scalable. It is a scalable concept. It can grow a lot, and it can be managed. It's designed to be managed. That's what it's made to do. This infrastructure is fundamentally robust. So, now let's talk about the blocks themselves. Let's focus down in on the blocks. Inside here is where your VLAN design takes effect. And VLANs do literally save the day. This is not just one flat network, so don't get fixed in your mind that this is one VLAN per block. It's not that way. A block could have many different VLANs. You could have 5 in a block. You could have 10, 15, or 20 VLANs if you wanted. Theoretically, you could have 20 different people there on 20 different VLANs. The beauty of VLANs is that as you add them, they don't slow you down one bit. Back in the day before we had VLANs, anytime you segmented an area, it was through a router. The only way a VLAN can communicate with another VLAN is through a router. And routers are slow. Well, they're not slow, but I mean by comparison to a switch, they're slow. However, once you move to a layer 3 switch, now you start caching information within the switch. And you use something known as Cisco Express Forwarding, or CEF, pronounced CEF in the industry. So you can use VLANs just as fast as if you didn't have them. So the number of your VLANs really don't slow down things in terms of brute force speed. And we're also not referring to making this unmanageable, as in micro-segmenting everything. Let's have a VLAN for every 2 people type situation. That's ridiculous, usually ridiculous. You're simply not going to need to worry about adding another VLAN as a slowing factor on your network. That's the whole point. It won't slow things down, not a bit. Not with layer 3 switches. There are no speed constraints here. It's as fast as the fundamental equipment is. And it will also, if designed properly, make management of your network easier. Ease of troubleshooting, for instance. You can check the user level, the physical port, the LAN itself, and upwards. You get better performance by limiting traffic. Sanity is safer too because it's easier to troubleshoot if things are controlled and constrained by boundaries defined by blocks. The daisy chains of switches, in that situation, you had to troubleshoot the whole thing that's strung together. I mean, if it's one flat architecture, you don't really know where the problem's from. This provides also, with a block-style construction, summarization points. It's easier to summarize within the network. The VLANs, you can define them within segments of summarization. So now you're probably thinking to yourself, okay, I took switches, not routing. So this means there's going to be less subnetting in the exams now, right? Wrong. Sorry, you're in for a surprise. You're going to be calculating some subnets here. Everywhere you turn in Cisco is going to be subnetting, no matter what. There won't be as much as if you had gone to Cisco route, but you still have to design your switch blocks, and for that you do have to, when they send up to the core, and you could be running, for instance, OSPF between these guys, or EIGRP. All this is layer 3. It's all IP based. What it is we're moving away from running spanning tree protocol near the top of the block, and we're moving on to routing protocols. Tuned routing protocols are the way to go. Now why? Well, routing protocols are simpler than spanning tree. They converge faster. More importantly, though, they're faster. Speed's the name of the game here. And if you use OSPF or EIGRP, you can tune it to where if any kind of a failure occurs, usually there's a switch over within milliseconds or sub-seconds at least, and you can now flip over and be using a new link. Your users aren't even aware of this change. It is that fast. So the beauty of that is that we now have layer 3 architectures up top here. So when these guys advertise their block, advertising, say, 172.16.8 through 15.0/24 subnet, you can use these as summarization points. Now, what I'm going to do is show you my flavor of subnetting here in summarization. And if you want a full description, you've just got to hop over to more like a CCNA, ICND2 discussion. That's where you'll find the detail on this, but I'm just going to sum this up quick here. I'm going to look at this and go, okay, this and this, these are the same bits between the two blocks. 172.16 are the same, so I'm going to come up with a summary address, and that means one network advertisement, and it'll encompass all of this here, 8 through 15, and all of this too, 0 through 7, into one network advertisement. And I'd look at 172.16, that octet, and we have 0 through 7 here and 8 through 15 over here, so in this case I'm using an increment of 8, right? I mean 0 through 7 is 8 numbers and 8 through 15 is 8 numbers. So what I would do is, in binary like this, it's 128, 64, 32, 16, and 8. Now again, I'm thinking in binary here, so these are my binary values, and that's my value of 8 over there, and the rest of these would be like 000.00 out. So my subnet mask would be 255.255, and this would be 248.0 like this. And right now some of you on the other side are probably saying, dude, what did you just do? You threw some numbers out, and wait a second, slow down. No, jump back to CCNA and ICND2, where I go over hours and hours of subnetting, and I talk all about that. I just don't want to go over it here in detail, but I'd say here's my increment of 8 right here. And so summary addresses that I would have would be 172.16.0.0, and then I'd just start adding 8. 172.16.8.0, 172.16.16.0, 172.16.24.0, and so on and so forth. Now I'm going here way further than I need because I only need 2 of those. So at this point I actually need to fill in the end ranges for those 2. So a summary address that would encompass this block of devices for 172.16.0.0 through 172.16.7.255. Now with 172.16.7.255 is the last IP before 172.16.8.0, so for 172.16.8.0 it's 172.16.15.255. So what I'm doing is looking at the next network right here and subtracting 1 from the IP address, and it helps me fill in the end range. So what I can do now here is say I'm going to advertise 172.16.0.0/21 subnet mask, or 255.255.248.0. It's the same thing actually. It's just 2 different ways of denoting subnet. And this guy over here will be 172.16.8.0/21, which essentially will point at this range right here, and this guy will point at the first range. So what I've done by doing this is I've kept my routing tables for my core very small actually, thus making my network very efficient to route when I'm designing this thing. So all of this, everything that I'm talking right here, all goes into VLAN design. Now, before I dive a little deeper into design, I want to take a sidebar for a moment and just step away from the techie stuff. When you're thinking about CISCO certification, for instance, even for switch, because design is a big part of not only what you'll do in the real world, but you'll be expected to do design in the exam. And this goes for any CISCO exam across the board. You're going to run into this style of question that I'm leading up to. Anytime you're taking a CISCO test and thinking about design questions, there will be two ways to see and approach a question. And I'll tell you that there's actually two different ways that you can feel about a question, because when you're taking exams, and I've taken a few of them, there's just a certain feeling that you get as you consider problems, and after a while you begin to quantize these feelings, and you can then discreetly ascertain what the focus of these considerations are. Now, you may get questions that are like, what's the best way to design this sort of architecture with a focus on some specific technology from the business organization's standpoint? And then you might get some other kind of questions that are asking, well, what's the best way to design this technically? What are some considerations that you just don't want to miss from the technical specification side? Now, those two types of approach, business organization and technical specification, I guarantee they're going to make you push the comment button as soon as you're working these types. You're going to say to yourself, this is a stupid question, or why would you ask me something like this? Because every answer is going to sound good. For instance, it might say, what would be the best thing for an organization to do? And it might suggest plan and design their subnets. Another response might be respond within the budgetary requirements, etc. And you'll be considering these answers, and you'll be thinking to yourself, well, an organization has to do all of these, actually. But the mindset, or the feeling I want to convey to you is this. When you're considering questions of this nature, what you've got to do is think about it from either an organizational perspective or from a technical perspective. You almost don't even need to have CISCO experience to answer these kinds of questions, because when you realize what you're dealing with, they're actually qualitative and not quantitative. For instance, you may have to ask yourself, would an organization really be focused on VLANs? No. Not really, they normally wouldn't. Imagine, for instance, a board meeting of executives for a quite large company, and the CEO, the COO, CFO, CIO, or any other officer you can think of is in the meeting, and they're all seated around a table discussing a technical change for the company. They're asking, how do we make our company successful? Is any one of these people really going to say, dude, you've got to go with VLANs and specific subnets and summarization routes. Those are the way to go. No, they're not going to say that. You'd have a bunch of executives just looking at the commenter and saying, who are you? How did you get in here? Because they don't want geek speak, usually. So if you're in an exam and you're confronted with an organizational requirement question, think of it as, this helps us save money. This helps us reduce technical support cost. Perhaps this helps us organize our data from market research, or it helps the receptionist do her job better. These types of things are organizational design requirements, and the organizational design requirements are part of the exams, guaranteed. It's in every CISCO exam in some form. Then there are technical design requirements. Do we care about the receptionist? Sure we do. Absolutely. But we really care about the bits and bytes, and what VLAN does that port belong to? What security permissions does that user have? And what can he or she do or not do? So I just wanted to step aside for a minute in the sidebar here to consider this topic, because I know a lot of you are going to be thinking about the exam, taking it, and I know a lot of these questions will just make you say to yourself, this is just bizarre, and it's a word game. And you'd be right, but just try to put the question in either one or the other mindset.